Okay, here we are, number 5. Plastic drinking straws are manufactured to fit in the drink cartons, which have a hole in the top. The straw can fit in the hole if the diameter of the straw is less than 3 millimeters. Normal distribution, the mean's 2.6, the standard deviation is 0.25. Okay, if a straw is chosen at random, find the probability it fits in the hole. Alright, so I'm just trying to find the probability. And it's a normal distribution. So let's go ahead and put our information together. We got a mean of 2.6. The variance is going to be 2.25 squared. And they want us to find the probability that x, the diameter, is less than 3. Now, you can see that 3 is bigger than the mean. So it's going to be, when I convert it to a z-score, it's going to be on the positive side. So that's good news because it wants it less than that, which my table happens to do. So the probability, all I got to do is convert it to a z-score. 3 minus 2.6, all divided by 0.25. And then I just got to change this to a z-score, 1.6. And then go to the table and find 1.6 along the side. And then find the probability that matches it. And the probability that I found was 0.9452. So, in part 2, we've got 500 straws chosen at random. All right, that sounds like trials to me. They want us to use a suitable approximation. All right, and it's at least 480 straws fit in the hole out of the 500. All right, so those 500, like I said, they feel like trials. And suitable approximation makes me feel like that this is a binomial distribution and they want me to use a normal distribution to find the probability. My check, if it fits, it's yes or no. So that fits the binomial criteria. So let's go ahead and put our information together. We got 500 trials. All right, so probability that it fits, well, we just figured that out in part 1. It's 0.9452. That's the probability it fits. That's why they had us figure it out. So make sure you don't use the rounded figure. But now I've got a probability of a success. And obviously I can figure out what the probability of a failure is going to be. So let's write our binomial distribution. We got 500 trials. Probability of success is 0.9452. All right, now if I switch it over to a normal distribution, I need a mean, so I multiply n times p, and I'm going to get 472.6. And then my variance is going to be the mean times q, which is 1 minus p. Anyway, all right, so let's go ahead and try this. We got to keep in mind, though, whenever we're doing a suitable approximation, that we have to do a continuous correction. And so we're looking at x is greater than 480 because we want it to be at least 480. All right, so our z, we're going to use 475.5 because we want to include the 480. All right, take away the mean, then divide by the square root of the variance. Use a bunch of digits. And then all we got to do is figure out what the z-score is because we're finding a probability and we just got to simplify this and figure out what the z-score is. So the z-score, when I do all that, I get 1.3558. So now I take my z-score and I go to the table. Well, actually, I look at my graph and I realize that it's positive. That's good, but the problem is it's going the wrong direction. My table is going to give it to me to the left. So I'm going to find the probability of it being less than this number, but then I'm going to take that probability away from 1, and it'll give me the probability that they really wanted. So 1 minus the probability, which is 0.9125, gives me the probability of 0.0875. That's everything to the right. All right, so they want us to justify it. Well, we only can use a normal approximation for a binomial if n times p is greater than 5, and if n times q is also greater than 5. So all you do is say that. 500 times 0.9452 is greater than 5, and 500 times 1 minus 0.9452, or you can actually do it if you want, is greater than 5. All right, now in 6, find out how many numbers are between 100 and 99, but the digits all have to be different. All right, so this is a counting principle problem, and what we've got to do is we've got our spaces here. We got the first spot, the second spot, and the third spot. We're just going to figure out how many choices we have. Well, there's 9 choices for this first spot. We go through 1 through 9. All right, now the second spot, we get to use everything but the one we used before, but we also have 0 through 9. So there's 10 minus 1 choices, or 9 choices. And then for my last one, now there are 8 choices, and those will give me 3 different numbers. And if I do 9 times 9 times 8, I get 648 different numbers, where each one of the digits is different. All right, now the next one, it says find out how many of the numbers in part 1 are odd numbers. All right, now for this, we're going to have to break it down into parts. All right, so, well, what's it look like? Well, if we're going bigger than 700, that means we've got some numbers that are in the 700s. And for that first digit, well, there's only one choice. It's going to have to be a 7. Now, for my next digit, I've got 0 through 9, but I've already used one of them. So that's 8 choices. And now for my last one. Now, for this to be an odd number, well, there's only, how many possibilities are there? There has to be an odd for it to be odd. So 3, 5, 7, 9, oh, and also 1. Okay, that last number has to be one of those for the whole number to be odd. So how many of them are there? Well, there are 5, but I've already used one of them. I used the 7 in the first digit. So that leaves me 4. So 1 times 8 times 4 is 32. Now I do it again for the 800s. Again, there's going to be 1 8. And now again, I have 8 choices for my next digit. And I need an odd. Now in this case, my first 2 digits have not used an odd number. So I can use all 5 as my choices. When I get to the 9s, I have 1 choice for 9. Again, 8 for the second one, but I've used a 9. For my last one, I only have 4 choices for the last odd number. Anyway, add those up, you get 104. That's 104 odd numbers in the group above 700. Now here I've got a bunch of flowers. It's a mixture of roses, tulips, and daffodils in the order of 7 flowers from the shop. All right, there's got to be 2 of each kind, and we got 6 roses, 5 tulips, 4 daffodils, and they're all different. So let's break this down. I got roses, and I got tulips, and I got daffodils. And there's different ways I can choose these, and just kind of imagine me picking them out. So combinations, if I have 6 available, and I'm only going to pick out 2 of the roses, and I got 5 available, and I'm only going to pick out 2, that's going to tell me the ways that can happen. In daffodils, 4, there's going to be 4, choose 3. Now together, that's going to be my 7 flowers, and that's going to give me 600. But that's not the only way I can do this. I could do 2 roses, and I could do 3 tulips and 2 daffodils. Well, that'll give me 900 ways I could do that. But that, again, is not the only way I could do it. I could take 3 roses and only 2 tulips and only 2 daffodils. And then when I get that, I got 1,200. Now, this is all the ways. I've just got to add them up, and it gives me a total of 2,700 different ways or bunches of flowers. All right, so number 7. I've got amount spent on shoppers, 160 shoppers, and it's summarized by this. And this is a frequency table, and the data has been grouped. All right, so first thing is make sure the table, when it's listed like this, the top one's usually going to be on the x-axis, and the bottom one's going to be on the y-axis. When we did this before, some people kind of screwed that up. So this is not a cumulative frequency table, but we can fix that. the first one will be 16, and the next one will be 40 plus 16. The next one will be 56 plus 48, and then 26 plus 104, and 30 plus 130. And now I've changed this to a cumulative frequency table, all right? And all I got to do is plot the points. Now, the points I'm going to plot are going to be the highest level in each grouping with the cumulative frequency. So it's going to be 30, 16, and then I'm going to plot 50, 56, and then I'm going to plot 70, 104, and then I'm going to plot 90 and 130, and then the last number I'm going to plot is going to be 140, 30. I'm sorry, not 30, 160. All right, so those are my points, and literally it just becomes plotting. Now, the biggest numbers are 140, 160, so I'm going to go up here by 20s and skip a space, and then I'm going to do the same thing across here. All I got to do is figure out what your biggest number is, and then pick an even number and go all the way across. And see, now I'm just going to plot points. So I go to 30 and plot 16, and I go to 50 and plot 56, and then 70, and then I go to 90, and then I go to 140. Those are my dots, and now I got to connect them. Now keep in mind, always make it go to 0, even though you may not have one, because anything that happened below the first thing is going to go to 0. And then you just connect these guys and try to make a straight line, unless they tell you to use a curve. All right? So make sure you label both axes. We got the number of shoppers and the amount spent, and don't extend the line further than the point, the information you have. And see, that gives us that. Now, part 2, I'm just going to do it on this because I'm going to use the graph. They want us to find the median, and what we got to do for that is find the total cumulative frequency and multiply it by 0.5, because we're doing an approximation. Well, 160 times 0.5 is 80, so I go over here to 80, and I come straight down, and you can tell that's going to land me right over on 60. So my median is going to be approximately 60. So now they want the interquartile range. Well, the interquartile range is going to be the third quartile minus the first quartile, and quartiles are 75% and 25%. So again, I use the same kind of process. I multiply times the largest number, 160. So now I've got 40, and I come across and then come down, and I'm estimating that it's a little bit less than 45, I think. So we'll say 43. And then I go up to 120 and come across, and I come straight down, and again it's going to be a little bit above the 80, and so I'm going to say not quite 85, we'll say 82, and now all I got to do is subtract those, 82 minus 43, and get 39. And there's going to be some leeway with this, but you want to try to make sure your lines are straight and your dream is accurate as possible. Now the last part, part 3, they want us to estimate the number of shoppers that spent more than $115. Okay, now this is going the other direction. I'm going to start with the amount spent and then go up, because that's what I know, the amount spent, and then I'm going to take it across here, and I can see that it's going to be somewhere around here. All right, so it looks like it's in the middle, not between 140 and 150. So I'm going to say it's going to be about 145, but it's going from 160 to 145. So the number of shoppers is going to be 160 minus 145. So I say it's 15. They'll accept 9 to 16. So again, you got to be careful, but there's going to be some leeway. Now this last one, they want us to calculate an estimate of the mean that's spent. We're not going to use the graph to do that. We're going to use the table, and it's kind of switching gears. All right, we don't need cumulative frequencies to do this. We've got to make sure that, because if you think about it, if I knew how much they spent and then the frequency was 16, all you do is multiply that number times 16 and then add it to the next number times 40 and the next number. Well, the thing is, because it's grouped, we have to estimate it, so we have to pick the middle number of each class times the frequency. And then we're going to add those up and then divide by the total frequency. And so this is going to be 15 times 16 plus 40 times 40 plus 60 times 48 plus 80 times 26. Whoops, how do we do this? All right, so if it's kind of add them up and then divide by 2, that's how we can figure out the middle. And we're going to get here 115. So it's going to be 115 times 30. And so we add all that up. And then we've got to divide by the total frequency, which we already know because we just did a cumulative frequency graph. And so we know that that's going to be 160. And so all I'm going to do now is just simplify this. Divide by 160. And I get 64.1 or $64.10. All right, that's all I got. I hope that helped. Thanks for watching.